Hello students, so welcome to ZCT191 Physics Practical I. So my name is Dr. John. You can call me Dr. John or Dr. Su. I generally teach astronomy courses in USM, so if you're interested in astronomy minor, you know who to talk to. Okay, so you are here because you're going to do the experiment called 1OS3 Geometrical Optics. Okay, so I assume that by now you would have downloaded your lab manual, and also you probably would have read it at least skimmed through it for once, right? So here you see me sitting in front of the equipment, and in a while I'm going to demonstrate to you how this experiment works. Okay, so but then again, for some of you, if you have not started reading the lab manual yet, I suggest that you need to go through a few things before we start. Right, so if you haven't, I would say that the basic things that you need to know for this experiment is that you need to know the thin lens equation. Okay, 1 over f equals to 1 over o plus 1 over I. You need to know the concept of a focal point. You need to know the properties of geometrical optics. So for example, if something is inverted, is it upright? If a lens is concave or convex, if an image is enlarged or reduced, or if the image is real or virtual. Okay, we also need to know what is magnification, okay, and what are the different formulas that are very similar to one another, and when do you use which kind of formulas. And then you also need to know a bit of what telescopes and microscopes are. Okay, so if you have not done this, if you have not read through the lab manual, I suggest that you pause this video and then have a rough read through, because I won't be going through all the theory for you, right? So I expect that you read that on your own time. Okay, so if you have done that, our first step is that we want to understand what this equipment over here is. Okay, so what do we have? First of all, this thing that you see, this entire thing here, is called the optics bench. Okay, and what we have on the optics bench is that you can see, right, that there is actually a scale, right? It's actually a ruler. It's 1.2 meters long, so you can see the entire scale of the entire thing. Okay, we have the viewing screen. The viewing screen, which is essentially just this thing over here, right? As you can see, that there is a plug that we can remove. Okay, this entire thing over here is the screen. Okay, and then we also have the geometrical sets, which is the 3 lenses. So here we have 3 lenses over here. This is a concave lens. Okay, it's a bit difficult to tell, right? But generally a concave lens is cave inwards. And then we have 2 convex lenses, right? So you can see me, right, in this sense, right? So which one has a higher magnification? You figure yourself, right? Because you can tell from the thickness of the lens. Okay, then you can know which one is, there are 2 numbers, right? So one is plus 20 cm, one is plus 10 cm. Okay, we also have the lens holders, right? So this is for holding the lenses. I'll talk about this more a little bit in a while. We have the light source, which I'm going to show you here. Okay, this is the light source. When I turn it on, right, there is going to be a shade, right? There's a cross arrow, and actually on the other side there's also just something like this. In fact, at the bottom you can actually do different kind of analysis with it, right? You can do 3 different colors. You can do diffraction as well. Okay, so multi-purpose, but we're only going to use this part of the light. Okay, finally we also have the paper grid, which is this thing over here. There is actually a secret message somewhere. I'm not sure if you can see it in the middle. Okay, and we'll figure that out in a while. And then just some rubber bands and all that. Okay, so you are not here to use the equipment. Unfortunately, but then again, usually there will be a lot of safety briefings, right, in terms of like how do you use them. The standard ones are, be careful with lenses, you don't want to break them. These are very expensive stuff. Okay, and of course, another precaution is on how do you actually put these lenses into the holders, right? So as you can see, everything here is, you can just like press it and then you can unclip it. Okay, you can lift it up and then you can just slot it in again. Okay, and then all these as well, you can just like flip it up a bit, sideways, twist it, and then you can just tap it in. Okay, the same for all the other things. Okay, so just to demonstrate to you how do we actually put the lenses on in case in the future you'll be using it, right? All these lenses have a diameter of 50 millimeters. So there is actually a scale on top of this holder. Okay, so if you look very closely, you can see a scale, okay, on the holder. So what we want to do is that there is a knob, okay, that we can actually turn this thing up or down. Okay, so what we want is that we want to keep these two at 50 because we know that the bottom two, right, these two on the bottom, we want to keep them at 50. Okay, because the lens has a diameter of 50. Okay, I'm going to clip it like this, and what we're going to do is that we're going to put the lens in here and then just slide this down and lock it. Okay, so let me just demonstrate it. I'll take the +20 lens. Okay, it's difficult to show everything on camera, so I'm going to put the lens slowly, okay, and then lock it in, tighten it. Okay, right, so now be very careful that you don't drop it. Okay, this is how it looks like. Okay, so depending on the situation, depending on the experiment, we are going to have 3 different lenses, so there's going to be a lot of taking in and out of the lenses. Okay, so if you ever do geometrical optics experiments, please be careful, don't break the lenses, and of course, never ever touch the sensor of the lens. Okay, just like your spectacles, right? You don't want to dirty your specs. So same thing, you want to make sure that the lens is fully clean. Okay. Okay, so now let's get into the first part of the experiment. Okay, so for starters, there are actually 4 parts in this experiment. Okay, they're actually very simple. Okay, it's probably some Form 6 kind of experiment that you probably have done before. Okay, so part A is basically a study on what is a focal length and also how do you measure magnification. Okay, so in this setup, it's very simple. First of all, you would want to have your light source, right, pin on the 0 point, okay, the 0 cm. So you just plug it in very carefully, and then you would want your screen to be at the 100 mark. So you just push it very carefully at the 100 mark. Okay, the next step is to put this plus 10 cm lens between them. Okay, so what it wants is that it wants you to put it close to the screen first, right, before you actually move it in focus. Okay, so what we're going to do is we're going to put this thing very close. Okay, so this light is going to shine through the lens, and basically you're going to see an image at the back of these. Right, so let's see if we can actually see it. Okay, so I'm going to push it a little bit further in the front until we see a well-defined image. Okay, I'm not sure if the camera actually is able to do this, right? So from my side, I can actually see a very well-defined image. Okay, so if I push it further, you see that it's not in focus. If I push it closer, by eye, it is a very well-resolved image over there. Okay. Okay, so now you know how it looks like. Okay, so another step that you need to do is that you are supposed to measure the size of the image and also the object. Okay, so let's take a look at the image first, shall we? Okay, so the image is actually quite small. Okay, you will need something like a ruler to help you to measure this very small thing. Okay, so you can use a caliper to measure the distance, or you can just use a ruler, right? So the caliper looks something like this, right? So basically it has marks in terms of centimeters. So if you reach this marks, it means that this is about 5 cm, this is about 1 cm. So it's not very helpful, isn't it? Right? So because of the too large a scale, so this is probably not going to help, because if I were to measure this top to bottom, you only know it's like 1 cm, but how many millimeters? So unfortunately not very helpful. So you can try to use a ruler to do it. So you measure that distance. After you've done it, okay, you have to measure the size of the object. So the size of the object obviously is this entire thing. You take a ruler, you measure from top to bottom, right? So in the image there was also the same thing, a circle, with a size top to bottom. So if you measure the circle size, then you would also have to measure the same object size. Okay, so once you got this position right, you want to record what is on the scale in table 1. Okay, so this is the 100 cm distance between the front and the back. You record this particular position. Okay, the next step is that you want to push this all the way to another different position, such that the image on the screen is also very clear. Okay, so what we're going to do is that we're actually going to put this somewhat close to, it's going to be quite close actually, right? This is not put properly. Okay, so we're going to put it quite close, such that it actually gives a better and a very clear image on the screen. So this is going to take a while. Okay, so for me, someone with spectacles, sometimes it can be a little bit difficult. And okay, I think I've generally got this well placed. And if you take a look at the image, okay, it's not very clear here. Okay, I look terrible in the picture, but yeah, so it looks like, the things are resolved. Okay, so for the next step is that you want to measure the size of this image and this object as well. Okay, as you may have noticed earlier on, you notice that the image size is actually quite large, right? This hand for scale, right? So this is a huge size image, and then you may not be able to measure it accurately, right? Because this is like just the center ring of the image, right? If you recall, the image looks like this. Okay, we're talking about the ring in the center. Okay, so if you can do that, well, why not? Okay, another way is that because this picture actually has gratings in it, so you can measure like the distance between two gratings, and then the same thing you can do here, right? You can see that you can measure the distance between the two lines in between, so be consistent. Okay, so if you measure this image, 2 lines, and you measure the image for the object, the same 2 lines as well. Okay? Okay, so what's next? After you've done measuring the positions, the 2 different positions, you've done measuring the object and the image size. The next, you're going to repeat this entire experiment by reducing this length, right, from it's originally 100 cm. So now we're going to move it to 90 cm. We're going to repeat the experiment again. So now we're going to move this over here. We're going to find the image that's very clear. Okay, and then we're going to move it over there to see another image again. And then literally we're just going to repeat this entire experiment. Okay, so for 80 cm, which is here, then the 70 cm, and then 60, and then the final one is 50. Okay, the only difference between these repeats is that you don't need to measure the object size anymore. You just want the object size for one particular situation, which was 100 cm once. Okay, so same thing for 50 cm. We can find that the image is getting smaller. Okay, as you can see over here. Okay, you can see that for 50 cm the image is getting smaller, and then you can also put this one over on this side, the image is actually getting bigger, right? If you can see, okay, from this part of view. Okay, so this is the measurement part of the experiment. The rest, of course, is analysis, where you're going to do at home. You're supposed to calculate the object distance, the image distance, find plot graphs based on the data that you get. Same thing, find the magnification, so I'll leave that to you. Okay? Okay, so let's do part B of the experiment. Okay, so part B is basically trying to teach you how to understand what are virtual images. Okay, so a quick recall is that real images can be projected onto a screen, while virtual images cannot. Okay, so we are going to test and find where the position of the virtual image that's going to be produced by a negative lens. Okay, so here in this setup, according to the equipment setup guide, right, so we put the minus 15 cm, which is this one over here, we're going to put it at the 30 cm mark, okay, and then we're going to put the light source at 10 cm mark, okay, so it looks like this. So as you can see, the 30 cm mark and the 10 cm mark, and then we're going to put the 20 cm lens on this side, okay, at the 65 cm mark, okay, and then we're going to place the viewing screen, this viewing screen here, behind the 20 cm lens, and we're going to move it to a position where we can see a very clear image, right? So now I'm just going to, for illustration purposes, this is very unclear, and then it's possibly the clearest around here. Okay? Alright, can you see it? You probably can't. To me it's clear. Right? And then yeah, so recall this is the image. Okay? So before you actually place the plus 20 cm lens, okay, there's one thing you need to do. You need to look through this minus 15 lens towards the light source and try to find the image. Okay, so if you look directly through the lens, you won't be able to see the image. But if you move just slightly further up, you will notice that there actually is an image somewhere here. Right, it is somewhere in the middle of space. Okay, I'm not sure if you can see it clearly. Yeah, it is actually an image, a virtual image of the light. And then you won't be able to project it on the screen because it is in front. Okay, so based on the looks of it, it does seem like this image is reduced. Okay, it's smaller, it is nearer to you compared to the light source, and it's hard for you to see from here, but generally it is an upright image. Okay. Okay, so what you have seen here is essentially a setup of two lenses, right? So imagine that the object is going to enter the concave lens, okay, and then the image is going to be virtual, and then that virtual image is going to be the object of the second lens, which is a convex lens, and then it's going to be projected onto the screen, which is a real image. Okay, so that means we can actually essentially find out where the image of the virtual image is, right, of this lens, okay, by removing this lens and moving this light source to a position such that, you know, the screen is also very well defined. That means very clear, okay, very sharp, and that's what we're going to do in this part. Okay, so we're now on page 9, step 6. We're going to remove negative lens from the bench, okay, and then the image on the screen should go out of focus as we expected to, okay, and then we're going to slide the light source such that we can see a clear image of the screen again. So we're going to do this, right? We're going to move it a little bit closer. Okay, so this is a bit difficult because it seems to be quite clear at least, right? So there might be quite a large error in between. Okay, for me, I find that it's somewhere around here. Okay. Okay, so does this look clear to you? It does seems to me. Okay, so it's a bit larger, it is clearer. Alright, so we have found the new position of this light source. So we need to record two things, right? One is the position of the screen, which is this particular position here, okay? And then the position of this new light source, right, which is about 24, okay? By right, you should be very careful, right? If you are actually recording this data, you really need to be very, very careful, especially because this, to illustrate, this image is actually very easily to be out of focus, okay, or rather not easy to focus. Okay, so by you see I've pushed it a bit, it still looks somewhat focused, right? So there's actually a very large range between that. Okay, so for demonstration purposes, you get the idea. Okay, so part 2, very simple. Just take the measurement for this part, take the measurement for this part, and then you're done. Okay, the rest are all just analysis. The analysis parts basically require to find the magnification, and then to find whether the object is enlarged, whether is it inverted, right, or whether is it smaller. Okay, and also you will need to you have to sketch out a scale diagram. So there's a graph paper given in your e-learn. You can just download it. You can copy paste it into your Microsoft Word, and then you can just draw arrow sizes based on the grid that you are given. Okay, so we're essentially done halfway through of the experiment, and let's continue to part C, where we are going to try to assemble a telescope, and then we'll see how it works. Okay, so in this experiment, I flipped the entire experiment setup the other way. Okay, so that we can have the screen on this side. Okay, I've removed the light source. We don't need the light source anymore, and then we need now the plus 20 cm lens. Okay, so now currently what we're doing is that we're actually looking towards the end or outside of the lab. Okay, so as you can see, right, we're trying to look outside of the lab. I don't think you can actually see what's out there. Let me see if I can zoom. Yeah, digital zoom. Right, so I'm trying to see the window because I think that's the best we can see. Right, we can't really go any further. I wish it was like a further place, that we can actually see. Okay, so the aim of a telescope basically is to look at the stars, right? So we want something that is at a distance close to infinity. In this case, this is not very infinite, but never mind. I think we have to make do with what we have. Okay, so we mount the 20 cm lens at the 80 centimeter mark over here, and then this is the screen being installed at the back. So what we're going to do is that we're going to move the viewing screen towards the lens, okay? And then we're trying to find a good image that we can see over here. Okay, so I've turned off the lights. If you may have noticed the difference in the lighting, right? So as you can see, this is the best. I would say the best I can do. Okay, ideally you want a very dark lab, but then again, if you don't have a lab that's very dark, I suppose we have to make do with it. So let's just put it out of focus. You can't see anything. Then you slowly go into focus. You actually see the entire lab. Okay, so I'm going to, yeah, I think that's about it. Okay, good. Okay, so compare this image that they have on the screen, right, as the light passes through the lens, with whatever is over there. Okay, somewhere over there. Right, so let's examine this image very carefully. First of all, if your eyes are sharp enough, you will notice that it's upside down. Okay, so this is like the bottom of the lab, the tree is growing upwards. So the entire image is upside down, so you can say it's inverted. Is the image enlarged or reduced? Well, I would say obviously it's reduced because the window is now so small, right? So the original window is large, so it's right. So we have a reduced image. And then, is this real? This is real. Okay, is this real life? This is real life. So this is a real image because it can be projected onto a screen. Okay, so next we are going to mount the 10 cm lens, the eyepiece, 10 cm behind the first image. Okay, so this is the 10 cm lens. We're going to put it about 10 centimeters behind the screen. Okay, so the screen is placed at 99, right? About 99, around there. So let's going to put it at 109. Okay, so we place it there. And this is essentially the telescope's length, right? So what we're doing is that this is the objective lens, and then this guy is the eyepiece, right? So you're going to actually see through the eyepiece to see what's outside. Okay, so we put that behind, and then this should make the length of the telescope should be about 30 centimeters, right? So let's check. It's 80 and about 109, 110. So it's about 30 centimeters. Okay, and then we're going to, it's about plus or minus because we want to see what we can do. Right, so then we're going to remove the viewing screen. Before you move the viewing screen, please have a very careful measure of the position of this screen. Okay, so I'll give it to you later. So once I remove it, the next step is to try to see through from the eyepiece. Okay, so we are going to see through the eyepiece. Let's try. Okay, I don't think this will work because obviously this is a video, right? So, but I'll just try to see myself first. Okay, so we're going to see through the eyepiece and look at what's far away. Okay. Okay, so the thing is that, in actual fact, you actually have to put your eyes quite close to the eyepiece. Right? Imagine that the eyepiece is actually something that you look through a telescope. So yeah, put your eye somewhere near it, and then move it a little bit, plus minus, to see a very good view. Okay, one more precaution, by the way, is that you want to look at the window on the opposite side. So basically we are trying to look at the furthest object. Okay, we are not supposed to focus, the image on the nearby things. Right? To give you an example, so when you're trying to look at this window, right, what you want to do is you're not trying to focus such that your image is clear for the blinds. Ooh, okay, this is a bit, right? You don't want to look at the blinds, you want to look at the furthest window, the furthest object, whatever that thing is there. Okay, and that is the aim of the focus. So I have roughly focused it, and if you see through the telescope, I'm not sure if it does work. Okay, this is going to be tricky. Alright, so yes, yeah, around there. Yep, seeing through two lenses, seeing the window. Okay, good. You see the window is upside down. Okay, so once you, so the main point is that you must make sure that your eyes are not squinting, right? Your eyes should be like just, the best situation that you can. The reason why you should not squint is because if you are squinting, that means you are actually trying to change, the focus of your eyeballs, right? You know how your eyeball works. The muscles actually help to reshape your eyeballs to focus on things. So essentially, we're looking at parallel rays coming from very far away. So it should, in this particular setup, it should, reduce the image. Okay, and then this eyepiece is going to magnify it, and you're going to make the light rays come out parallel. Okay, our eyes are the best adapted to parallel rays. Okay, so when they go in parallel, you are the most comfortable position, and you can look at something that's far away. Okay, so once you have got this done, you're going to record the position of the eyepiece, which is around, I would say, 105 or so. Okay, it really depends. Okay, so we are almost done. Alright, so now we are left with the final part of the experiment, which is part D, where we are going to basically try to do a demonstration of a microscope. Okay, so as you can see that we have set up the equipment slightly closer to this part, right? The microscope basically is trying to enlarge something small. So first of all, we will have the 10 cm lens at the 60 centimeter mark, right? And then step 2 is to install the light source at 45, right? So let's take a look, right? So we have this lens at 60. Come on, focus. Okay, why are you not focusing? All right, so and then this one is at the 45 mark. Yes, focus. Yeah, so 45 and then 60. And then you want to put the screen towards the end of it. And then you want to push it forward towards the screen, towards the lens until you see a sharp image. Okay, which I kind of cheated. Almost got it ready before I film it. Okay, so that's around here. Okay, good. Okay, by the way, one tip for you is that sometimes, you know, when you try to focus something, focusing between things that are clear at the sides and things that are clear in the middle may be a bit different, right? So sometimes it may be clearer in the middle, but the side is not clear, or sometimes it may be the sides that are clear, but the middle is not. As to why is that, that would be a very good Viva question to ask. Okay, so what's next? So now we want to put the 20 cm lens directly behind of this screen. Okay, so here we have the 20 cm lens. Okay, and then once we put it behind the screen, we're going to look through it as we move away from the viewing screen. Okay, so we want to look at the back of this screen, by the way. Okay, so we're not trying to look at anything else. And to help you, sometimes you can put something around here to see it. Okay, so let's see if we can get it done. Okay, so what you have here is this lens. Okay, I can't go any shorter right around here. So what you want is that you want to see through this lens such that, you know, you get the best view. Okay, that is very, very well, you know, focused. Okay, it's a bit difficult sometimes around there. Okay, your eye has to be close to the lens, by the way. Okay, so sometimes if you really can't see whether is it very well focused, you could try to use like a piece of paper, right? So that because there are smaller words, right, in between. So it does look rather well focused to me. Okay, at least, right? So let me just try to see if I can do it. Okay, it does look very well focused. I move it further, it's not focused, and now it seems rather focused. Okay, so it does seem like it is focused. Okay, so you can see it, right? Light source, this thing, and this one over here. Okay, so what's the next step? We're going to remove the viewing screen and remove the light source. Okay, before we do that, let's just double check the position of the screen. Remember to measure the position of the screen first before you do anything. Okay, so one more thing is that you have to first look at the first image, if it's upright, inverted, enlarged, reduced, or real. Yes, this is something that we haven't done yet. Okay, so let's go back to step 4. Right, so step 4, once we had this image on here, we haven't actually determined what kind of image is it. Okay, so is the image inverted? As you can see, the arrow is pointing downwards, so it's actually inverted because the arrow over here is actually pointing upwards, as you can see. Alright, so it's an inverted image. It is obviously enlarged, right, compared to the actual size of the image, of the object, and then it's obviously real because it can be projected onto the screen. Okay, so now we jump back to step 7, where we remove the viewing screen and the light source. Okay, so I'm going to remove this screen. I'm going to turn off the light source over here. Okay, and I'm going to remove it. Okay, so what are we trying to do? Okay, I suppose you, so we have actually measured the position of the screen. Okay, so the next step is that we want to use a rubber band to hold a copy of the grid on the viewing screen and place the screen in the exact position where the light source used to be. Okay, and the light source used to be at 45, right? So let's take the grid, right? It's a rubber band, it's a grid, okay? I suppose you don't really need to see a demonstration of how to tie a grid onto the screen, but anyway, let's just do it. Okay, so there's actually something secretive about this screen. There's a very small message that's on top of it. Okay, so and what I'm going to do is I'm going to make sure that this message is upside down on the screen, which I'll explain later, right? So basically just try to place it in the center. You know, sometimes I feel like I'm doing a cooking show and I'm trying to teach you how to cook. Okay, so I'm just going to tie it like this, right? It should work, right? And then we're going to put this screen back on top, right? At the 45 mark, which is here, right? Which is exactly where the light source was earlier on. Okay? Okay, now what we are going to do is that we are going to view through this lens over here, which is going to be the eyepiece. Okay, the eyepiece is the 20 cm lens, and then the objective of the telescope is the 10 cm lens. And you notice that there's a flip between the telescope. Okay, and we're going to look through the eyepiece and until we find the image of the small message. Okay, and then we're going to adjust the grid. We're also going to adjust the eyepiece, okay, such that we can see it very clearly. Okay, so let's try to see if we can do that. Okay, so as we look through the objective eyepiece, we see, I'm not sure if you are seeing what I'm seeing, but it says physics is fun. Agree or disagree, right? You have to agree because you're doing physics experiments anyway. Okay, so it seems like it's very well focused, at least to me. I'm going to try to use my eye to see, right? It does look like it's rather focused. Okay, at least at the center as I can see it, right? Okay, so are we done? Yes, I think so. Okay, so what we have here is we need to record the position of the eyepiece, which is about 111 or so, and then we're done. That is table 4. Okay? So, what do you think of the experiment? It's not very difficult. So, as you can see, that basically what we have done is that we have tried to understand how the lenses work. In this case, a telescope, microscope configurations, both using 2 lenses and 2 converging lenses as well. Okay, questions that you may think or you may ask yourself is it possible to make a telescope with 1 converging and 1 diverging lens? Is it possible to use mirrors to make telescopes? How about using mirrors to make microscopes and all that? Okay, and so you need to pay attention to the analysis, right? So for part C and part D, I didn't mention most of the analysis. In fact, most of the analysis is to find object distances and image distances, which you can figure out from the instructions and using the correct equations. Okay, and then finally, of course, is the magnifications. So magnifications can be in terms of the objective lens or even the eyepiece. Okay, and also the magnification of the entire system, either the telescope or the microscope. Okay, so do your analysis, spend the next few hours trying to understand you will be able to get your data, simulated data on the website, on eLearn, according to your groups, right? Different groups will have different data. Input the data into your Excel file and then try to use your Excel file to make use of some formulas to find the answers, to plot the graphs, and after that, then I think you should be almost done. Okay, so I suppose that's all from me for now. get started with your report, and then I'll see you for your Viva and Nova. Okay? Good luck.